So, in the beginning of chapter 13, we are going to be working with right triangle trig to start. Trigonometry can be done on right triangles. It can also be done on any triangle in general. But we're going to begin with right triangle. In a right triangle, there are three sides, one of which is very special. Across from the right angle, we have what is called the hypotenuse. Then when we do trig, what we do is we choose one angle on which to place our focus, and we call that angle usually theta. It's an O with a line in it. It's a Greek letter, theta. So we choose one angle on which to place our focus, and then we name the other sides of the triangle according to their relationship with that angle.
It's called theta?
Theta. Yep.
Isn't that just the variable?
Yes. Yep. Theta is just another letter we can use as a variable. It's a Greek letter for a variable that typically means an angle. We can choose either of the acute angles to be theta, not the 90-degree angle. We're not going to use the 90-degree angle. And once we've selected the angle to be the theta, sometimes it will be selected for you, sometimes you get to pick. And we the triangle according to the relationship with that angle. So we have an opposite side, which is directly across the triangle from that theta, and then the adjacent side is next to. That's actually what adjacent means, is next to or touching. So the side that's next to or touching that angle, then we call the adjacent side. And then again, the hypotenuse is always across from the right angle. Once we have labeled the three sides of the triangle, we have 6 different trig fractions we can set up according to those sides. We remember these fractions with the phrase SOHCAHTOA sometimes. Each letter in the name SOHCAHTOA means something. So S is sine, OH, opposite over hypotenuse. C is cosine, AH, adjacent over hypotenuse. T is tangent, OA, opposite over adjacent. SOHCAHTOA is really helpful to remember what those 3 fractions are if you remember how to spell it. If you can't spell it, you've got nothing, because it's all about the spelling of that word. So other students make up stories or phrases that use each letter. So I know my teachers use the phrase, Oscar had a heap of apples, just taking not the SC and the T, but the letters inside there and making a story. Whatever it takes for you to remember what these fractions are. You need to know all 6 of our trig ratio fractions. So sine, cosine, and tangent are fractions we memorize according to the word SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. The other 3 trig ratios are the reciprocals of the first 3. So if we take sine and flip it over, it becomes hypotenuse over opposite, and we call that cosecant. If we take cosine and flip it over, it becomes hypotenuse over adjacent, which we call secant. If we take tangent and flip it over, it becomes adjacent over opposite, which we call cotangent. One thing to be cautious of when you're doing the flipping, make sure you notice that sine becomes cosecant and cosine becomes secant. Okay, so when we flip it over, the C and the S switch up too. Okay? A lot of times students want cosine to go with cosecant. Okay, but when we flip it over and take the reciprocal, those letters switch up as well. We're not going to worry about the bottom 2 rows of the chart for now. We will worry about that stuff later. You also have a couple of special triangle patterns that you have to memorize. The first one is the 30, 60, 90 triangle. In the 30, 60, 90, we say that the short side across from the 30 has a length of 1. The hypotenuse is double the short leg, and the longer leg is the square root of 3 times as long as the shorter leg. Now, it's not always 1, 2, and square root of 3, but it always follows this pattern, that the hypotenuse is doubled, and the longer leg is times the square root of 3. So, if, for example, the shorter leg was 6, how long would the hypotenuse be? 12. It's going to be double it, and the longer leg would be 6 times the square root of 3. It's not pretty, and we just leave it that way. Okay. The second pattern is the 45, 45, 90. It's isosceles. since two angles are the same, so both legs have a length of 1, and the hypotenuse is square root of 2 times as long. So if, for example, one of the legs had a length of 4, what would the length of the hypotenuse be? 4 times the square root of 2. Okay. So these patterns need to be memorized as well as the SOHCAHTOA stuff. Lots of stuff to memorize when we come to trig. So for our first problem, it asks us to evaluate the 6 trig functions as shown in the triangle. And my theta didn't copy over, but your theta should be there in the top angle. So what we need to do first is label the sides of the triangle according to the relationship with theta. The hypotenuse is already labeled. What kind of a side is 4? The opposite, which would make 3b the adjacent. We also need to know what all 3 of the sides of the triangle are. So we know 3 and 4. We need to find the third side. How do we find a third side in a right triangle? Pythagorean theorem, which is a squared plus b squared equals c squared. What's important about plugging stuff into the Pythagorean theorem? Side C has to be the hypotenuse. That's the biggest mistake that students make with the Pythagorean theorem, is letting C be whatever you happen to be looking for in the question, but C has to be the hypotenuse. In this question, that is what we're looking for. But C must always be the hypotenuse. So for this question, we're going to say 3 squared plus 4 squared equals C squared. So that's 9 plus 16. 25 is C squared. So that means our hypotenuse has a length of 5. 3, 4, 5 is kind of a special triangle for us. It comes up a lot because the numbers are nice and clean. Now, the question wants us to list the 6 trig functions. So we're going to say sine of theta. You must always have an angle after a trig name. Sine can never exist just by itself. It must always have an angle following it. Either the name of an angle, like theta or x or something like that, or the size of an angle, like 64 degrees. But you must always have an angle that follows a trig name. A trig name, sine, cosine, tangent, can never exist just by themselves. So sine of theta, sine is opposite over hypotenuse, so that would be 4 over 5. Cosine of theta is adjacent over hypotenuse, that would be 3 over 5. And tangent of theta is opposite over adjacent, so 4 over 3. The other 3 are the reciprocals. So sine flips over to make cosecant. Cosine flips over to make secant. And tangent flips over to make cotangent. We don't have any other solving to do with these. We just want to list them. Questions?
It's not just one problem, or is that not even scratching the surface of what we're doing?
This is the first type of problem that will appear on your homework. Go ahead and try the next one. Okay, so the first thing we need to do is label the sides according to the relationship with theta. So adjacent is already labeled. 13 is the hypotenuse across from the right angle, and 12 is the opposite across from the angle that's labeled theta. Then we need to find out how long all of the sides are. For that, we use our Pythagorean theorem. And it's important that C is always the hypotenuse. So in this one, we would say 12 squared plus b squared equals 13 squared. It doesn't matter what a and b are. So if you did a squared plus 12 squared, that's fine. But C has to be 13. C is not just what we're looking for. C is the hypotenuse, which we actually know in this question. So that's 144 plus b squared is 169. Subtract out and we get b squared is 25. Gives us a side of 5. 5, 12, 13 is again a common set of numbers that comes up because they're all nice clean numbers. So now that we know what all the sides are and we have them labeled, we can find our 6 trig functions. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Then we flip to find the other 3. Cosecant flips over sine. Secant flips over the cosine. And cotangent flips over the tangent. Questions? Okay, as a side note, these problems both worked out nicely for that third side. That may not always be the case. Read that will not always be the case on your homework. So, let's say this was our question. If I want to find the third side of this triangle, I would need to do 5 squared plus 10 squared equals c squared. 25 plus 100 is c squared. 125 is c squared, and take a square root. The square root of 125 is not a pretty number. Decimals are not appropriate answers unless the directions say estimate, approximate, or use a calculator. And the directions for these questions do not. So we need to simplify that square root. How do I do that?
You could say square root of 25 is times square root of 3.
Okay, so 25 goes into 125 5 times. And the square root of 25 is 5. So we get 5 square roots of 5 for the third side. Then, when you go to find your trig functions, say for example sine, what's the opposite? 5, and the hypotenuse is 5 square roots of 5. Reduce. So I get 1 over square root of 5. I'm going to ask that you please do not rationalize. Leave square roots on the bottom of the fractions. We've learned before that that's considered to be kind of inappropriate, but when it comes to trig, we let it go pretty often, and I want you to please not rationalize. Now what that means is when you go to check your answers in the back of the book, they're not going to match what you have. But one of the main reasons why I don't want you to rationalize is after we find sine, we would want to find cosecant, which is the reciprocal. And if I fixed it and then I would flip it over, it's going to become unfixed. Okay, so it just puts us in this whole loop of having a whole lot more steps. So I'm trying to save you work by asking you to please not rationalize. But that does mean that checking the answers in the back of the book will be more difficult. What you can do is type in your answer to your calculator, type in their answer to your calculator, and you should get the same messy decimal. And that will work for checking your answers. Question?
Was that an example that you just drew yourself?
The first question actually has these numbers in it, but I don't know if theta is in the same location. But it does have 5 and 10 in the first question on the homework.
So square root of 5 over 1 is wrong.
Square root of 5 over 1 is correct for the cosecant.
Yeah, if it was sine.
When I flip over sine, I get cosecant. So these are 2 of the 6 answers.
Yes. But so, you didn't want us to rationalize.
I do not want you to
You
rationalize.
just want us to have 5 over function square root of 5 for sine.
Right, if we rationalized for sine, we would get square root of 5 over 5, and that's what the back of the book would say, but I don't want you to do that.
Oh,
Mrs. String,
Yes.
did you tell us last lesson that we weren't just allowed to reduce half part of a fraction or whatever?
When adding or subtracting, you cannot reduce a portion of the fraction. When multiplying, you can reduce parts of fractions. Because multiplying and dividing are partner operations, but adding and dividing are not.
Can you explain how you're knowing the opposite and adjacent?
I draw arrows if I'm having trouble seeing it. The hypotenuse is always across from the right angle, so I can draw an angle from that little right angle thing, and what it points to will be my hypotenuse. And then draw an arrow from kind of like right down the middle of the angle, and what it points to will be the opposite. And then the leftover has to be the adjacent. Okay, back to the